Hello, our project is about the WEG SSW07 soft started. The motor we use is Toshiba EQP Global SD. This word is for the subject powers electronics. In this project, we show the basic setup of the sub-started. We use the kit setup manual from the company. We use we use the motor data to configure voltage and current and torque. The motor is Toshiba EQP Global SD. It has 30 horsepower or 22 kilowatts. The voltage is 230 or 460 volts. The current is 20 second ampere amps at 20 two, 3 to 30 volts or 36 amps at 460 volts. The spend is 1,770 RPM. First, we set motors data from the nameplate. We select the control type. We adjust acceleration and deceleration ramps. We set protections. Then we confirm correct operations. We can use 2 or 3 rate control. The motor starts with a smooth voltage ramp. The stop can because or deceleration ramp. Kit start helps when the motor needs high torque. The sub start shows input of and output voltage in real time. The voltage is on the keypad display. This helps check correct connections and operations.
Okay, so now for the display of soft start current, we're gonna use the soft start continuous motors to monitoring, okay? The display real-time current, it could be the line current, and useful for checking in rush current and load conditions. Okay, the monitoring parameters are divided for four combinations. In the first time, the P003 is for the motor current. We will see in the display the value of the current in that moment. In the same time is will be the P007 about the voltage, P006 about the soft storage status, and finally is the P004 about the motor speed estimation. The torque, it will be estimated from the current and voltage. In the same time was showing by this display. These parameters ensure correct motor monitoring. The troubleshooting and diagnostic, it will be managed by LED indicators. It's about our current phase loss or phase sequencing. At the same time, it will be a fault reset via D12, no, D12, common alerts about our current, under voltage and false imbalance. and at the same time, finally, quick diagnostic improve reliability. The protection and limits, it could be about model overload protection about the thermal class, the current limit function about the percent of nominal current, the phase loss and sequence monitoring, and safeguards models and power supply. It will be managed about the coded named by bit 600, bit 601, and bit 602. The first one, it will be about motor overload class. The next one is about electronic motor protection. And the last one is could be about the restart atoms. Okay, this is a sample about our model. Okay, so if we want to put the parameters in the display, well, in the first time it could be about the voltage, the rate voltage, and we have to manage the HMI, putting the P 400 combination in the display. In the same time, we can manage the value. In this, well, in this example, we will put the value about 460 voltage. It could be at the same time about the rate current using the code P401, and we put the value 36 amperes. And the next one, it could be run uptime using the code P102. Well, in that example, we use 10 seconds. And finally, we use the run downtime using the code P103. We gonna use the time of 5 seconds. Okay, the summary about the presentation is about the quick setup, simplest parametrization through the HMI that the drivers offers to the user. Okay, the motor nameplate data ensures accuracy. The voltage, current, and torque can be monitored, as I explained, and my teammate explained previously. The protection features safeguard system and a relief operation in industrial application. Okay, so well, this is all for now. We thank you and see you in the next time. Thank you.